Alright, back on what makes this shaft. Right here's the components. What makes this turn when you put electric on this? That was the question, correct? Alright. Well, as we discussed just prior, that these are connected. When you have 3 wires coming out here, now we got a wad here, but when we connect this motor properly, you're going to have 3 leads coming out of it. You're going to tie your A, B, and C phase to that on your engine. And when it does that, it energizes this copper in this stator, creates a magnetic field. This chunk of iron and aluminum inside that, as that electric goes in on A phase, it circles through and comes out B phase and back into C. As it does that, as it follows that path through that motor, this shaft turns. So all this is turning by is by magnetics, a magnetic field created by electricity. So any questions on that?
Why does it pull so much more current when it's not up to speed than it does when it gets up to speed?
Okay. We are setting steel. Okay. It's just like, and I'll use this as an example. I'm sitting in my chair, relaxed. To get up and do something, I've got to, so it takes more energy to get up and get started than it does to continue walking. Okay, it takes more energy. This is setting steel, so we've got to get this turning. So it's exerting its energy to get this chunk of steel turning, plus whatever load we're turning. You know, and that varies too. I mean, startups can be anywhere from a half a second to, shoot, these startups that take, I was on a machine the other day that took 10 minutes for it to get up to speed.
So what is, in a single phase then, I know I've heard the guys say, I mean, starting capacitor, but then like on your 3-phase, we, on our pumps down at our river station, we have soft starts.
Yes.
Is it the same principle?
A soft start, what it's doing, say we've got a 460 volt or 480 volts power, incoming power. What it's doing, it's variabling your voltage up. So say it starts the motor out at, it's probably going to give you an initial boost of say 100 volts. Or it might even be 200. You know, it depends on the manufacturer, the soft start and the application. But it's going to give you a boost of energy to begin with, and then it's going to ramp that voltage up through the start cycle, however long you tell it. And if you noticed, a lot of times, I don't know how many people's in here is fooled with the soft starts. Of course, we'll get into this more in controls, but they're, you know, they can be, you set them for 30 seconds and your motor starts up and runs full speed in 5 seconds. How many people seen that? That's because your motor ain't under a lot of load starting. But we'll get into all of that later. Any more questions on this theory? And I want you to ask these questions because this is important. When you understand how stuff works, it's a lot easier to fix. To me it is.
Soft start's more for a ramp up slow versus kicking it off hard from the get-go, correct?
Correct.
It's more easier on all the other equipment. So it's a slower gradual versus, you know, putting something in gear and punching the gas to the flow very good.
Exactly.
It moves it slow until it gets it up, right?
That's exactly right.
They do it a lot in water with applications to decrease water handling.
Yeah.
Same thing with VFDs.
Yes.
It's a lot more expensive.
Yeah. And as I said, when we get into the components of the control panels, we'll talk about drives and soft starts and all the different controls a lot more.
So the energy goes in, does it come out, man?
Yes, it's just a path. Okay? I mean, when you plug your wall outlet, you've got 2 wires coming from the plug. They go out there. If it ain't got anywheres to go, it just sits there and nothing's gonna happen. When you complete that circuit, if you touch them two wires together, boom, you get an arc, correct? Now, what this does is when you touch those two wires together, it creates energy. It's using the energy in that, and it's just a circuit. It's a path. It's like the water. Y'all all familiar with the water. You pump it from the river through the water plant, goes out to everybody's house, through the commode, back to the sewer plant, back to the river, the next town down the river, pumps it back through the water plant. You know, I mean, it's just a recycling. And so this energy, but you are using the energy that you are generating here, so.
So it goes in A, out B, and back through C.
And it's just a circuit, it's just a flow. It's just like electricity is just like water pipe. It's gotta go somewhere. If you ever look at an electrical schematic, how many of you ever looked at there and say, oh, I'm in trouble? Well, if you put your thinking cap on and sit down and think and really get to looking, it just flows. And you just watch where it goes. And you've got little contacts or contactors in there, and you have to know all of those symbols on the drawings to understand it. But when you understand those, then this electricity runs through this switch, it runs up through this switch, and it's just a flow. And those switches is just like your valves in your water pipes. You just open a valve and it goes on down to here. So electricity has to flow. Does that help you any?
Yeah.
Okay. Anybody else got any questions about the theory of what makes the motor work and the components of a motor?
Hey, David. I had to ask you this about the windings when we were over at the plant, but the windings are in a loop,
Yeah.
and it's not like a big wire that goes through there. It's a series of small wires, and the windings, every one of those is insulated.
Yes.
So they're protected against each other. So just because they're in the same coil, each one of them is an individual wire.
If you look on page 16 in your book, it's got a good picture you can see. You see all of these wires in there, all those little copper wires. That's just what you're seeing in this motor right here. Okay? Any two of them wires get together, you got a short. Well, let me back up. Any two wires that's out of the same turn get together is a short. We can have them in the same turn, but that's shop terminology. So, but any two wires touch, you've got a short.
Talk about going in A, B, C. A, B, and C phases are separate. They emit through, they don't actually touch. It's all to do with magnetics and transferring of currents, sort of like eddy currents. It transfers, it don't touch. A, B, and C phase never touch.
Right.
Okay, I think a lot of conversation's been about them all going in.
Well, yes, but they actually are separated.
Okay.
But they are. Let me draw this out. Anybody got it? Let me see if I got it.
A, B, or C,
Right.
Let me draw this out.
They're not actually physically. It's sort of like a transformer. A transformer puts in one out the other. If that's a magnetic field,
All right.
makes the other current.
I'm going to show you how a motor is connected to make it work. You have A, B, and C phase. You have A phase. Okay? And I'm going to put some numbers up here so I've got some terminology, but this is discussed later in the connection diagram. But we have 1 and 4. That's my A phase. okay? This is motor lead terminology. B phase, we have 2 and 5. C phase, 3 and 6. All right, this is making up the motor circuit. To make this motor run, I've got to connect the end of C to the beginning of A. I've got to connect the end of this, the end of A to the beginning of B. And the end of B to the beginning of C. And I have 3 leads. And that is the connection. The end of A phase, connect to the beginning of B. Does that help you?
Yes and no.
I'm a little
It's clear,
confused.
it's clear as muddy water, so let's move on.
No, well, I'm a little confused about what I'm not understanding, I guess.
So
what
if you
you're
take
asking.
A phase and touch it over B phase, where it comes into the makeup point, it's gonna short out. It's gonna blow something, because you're
Yes.
shorting phase to phase.
Yeah, exactly.
But yet, where you got that drawn, it's got phase A and phase B.
It does. But that's how it flows through the system. See, if I just connect,
It's a big loop.
Right.
if I just connect, if I take this loop out and I just put power on them 2 lines, there's nothing there.
Right.
There's no place for the energy to go.
Right.
So
So it
just,
is physically inside the windings, it is physically.
yes, it is connected.
Okay.
From one end to the other. It's just like a welder. You take a welder lead, everybody in here welded before? All right, you take a welder, 2 leads sitting out here, they don't do nothing. You touch them together, you get an energy, and it melts the steel. It doesn't work. It's just like the motor. When you connect the 2 phases, when you connect these together, it creates the circuit, the path of electricity for the electricity to create energy.
So you charge each one of the coils, and then that makes the motor turn. That's how you get the power into the motor, right?
Yes, we're gonna, this motor, this gets into a lot of, we can spend days and days on motor.
Basics, one goes on one side of the
Right.
pole, one goes in the other, and it makes it.
Right, all this does is this electricity just comes in here and it flows around through here, okay? Right around in a circle. And these phases is laid in here, inside the motor. I don't know if we can do it, but I'll see if I can get some pictures of some motor winding happening that we can put up on the board. I'll see if I can get Luke to do this at break, get some pictures off my phone onto the slideshow, and maybe we can understand a little more. It'll help you all understand what I'm talking about, because this gets into a lot of theory that's not really applied, I guess, in your field. It gets applied in mine, where we're in the shop working, but it also helps when you know this. It does help when you come to troubleshooting the motor.
Layman's terms, obviously 3-phase is more energy efficient than single phase. But why?
Higher volts, lower rates.
Theory, you get a little lower voltage, or you get a lower amp draw, but arc current, which is what we all pay on, wattage, which is what we pay on, it don't matter if you've got 1,000 volts or 115 volts times amps is watts, plus some other figures if you want to really get into the scientifics of it, but for the most part, volts times amps. So, it's pretty much if you've got 1,000 volts or 115 volts. 1,000 volts, you've got less amps, but you still got your watts up here, because it's volts times amps. Down here, 115, your amps go way up, so it's the same figure. But what you get into is construction costs. It's a lot cheaper to run wire as big as your pinky than it is wire this big around. If you understand.
Just a quick question, we have a dredge in all of our reservoirs, remove sedimentations, three-phase. We hooked up a step-down transformer to get 110 or 120 voltage in there, just to, run a radio, a little heater, whatnot. One of the fuses on the pole had failed, and it opened up. So, we were trying to figure it out before we realized the pole, but we had power. We still had power at our outlet for the transformer step down, but the motor would sit there. So then, basically, you've got energy coming in. You had it coming in at A.
You got that right there, and this right here is left over.
Okay. So that's.
Theoretically, it's called single phase, it's, one of the hardest things to understand is we use three phase. I don't know where the power company gets this. We use three phase electricity.
Is there dual phase?
Single phase.
The single one?
Single phase. There is two phase. To answer everybody's questions, I'll give you a little brief story on the two phase electric. But single phase, we call it single phase. That's what everybody's got at their house. A lot, it's pretty much a residential use. But there you see some commercial. Two phase. We had a motor come in the shop a few years ago, and I didn't have a clue. I mean, this thing is, you lift the connection up. When you get a motor in, just so everybody knows, when you get a motor in, it's got to be rewound. All this copper's got to come out. You make loops of copper, you put it back in here by hand. That's the way they're landed. Now, the manufacturers of these motors, they have machines that wind them. But in all your repair facilities, they do wind by hand. They insert them in here by hand. But anyways, so you have to physically lift these out. And when you take the copper out of this motor, you have to count it to know what you got. So we've been in business 3 or 4 years, and we get this motor in. It's not much bigger than this, but it's really odd. And I'm messing with it, and it's got a really weird connection. It's got 4 leads, so I'm thinking single phase. And I'm like, but I just don't know. I send my dad off. We are a member of ESA. You'll see some of their stuff on here. It's Electrical Apparatus Service Association. We have 4 or 5 engineers on staff that we have access to that I can get about any answer I want. Anyway, so I sent him the data this morning. She says, hey David, you've got a 2-phase motor. I said, 2-phase? Who's ever heard of a 2-phase? She said, well, there's two pockets of 2-phase electricity left in the United States. One in New Jersey, I believe, she said on the East Coast, I believe up around New Jersey or Rhode Island, somewhere over there. She said the other one's in Litchfield, Kentucky. Well, I've got a motor out of Blank, Litchfield, Kentucky, a 2-phase motor. Odd. I've been winding them motors, that was in probably 2002. They're on some kind of machine, and they've got 3-phase in their plant they run most of the stuff on. But they're called manipulators that they use these motors on. And I've been winding probably 4 or 5 a year for, I don't know, for the last 10 years or 12.
Is it German?
I don't know. I have no idea. There's no names on it, on the motor or nothing. It's just a housing. And it's pretty simple, and as I said, we've wound 4 or 5 years for the last 10 years. But just to let everybody know, if you ever hear somebody say there ain't no such thing as 2-phase, you can win a bet.
New Jersey and Kentucky.
You better get his phone number so you can use fact checks.
So it's more, I don't want to keep leading off of it, but like a 2-phase, is there a difference in hertz then?
No.
It's the same?
I don't know. When you get into that kind of,
Because our norm is 60, right? So everything's the same.
yes.
That's what I don't, we're 60 through the United
We're
States.
60 hertz through the United States, Europe's 50, so some 50 hertz in Canada. Different places in the world's different. For the most part, you'll see some machinery here that's labeled, if you get in a lot of foreign equipment at your plant, you'll see stuff that's labeled for 50 hertz. 9 times out of 10, you're gonna run it at 60, so don't worry about it. I mean, usually the 50 or 60 hertz, I'll probably get in trouble for saying this, but usually the 50 or 60 hertz stuff will never change. So, I mean, you're just gonna run it, 50 hertz, 1800 RPM motors at 1600 or 1400, whatever the ratio is there. So, you know, it's just gonna run it at 1800 instead of 1400.
Well, that's like on CFDs, like you're adjusting the frequency.
Right, yes.
Because we've had that where we're putting a 50 hertz motor, put on a VFT, and you just dial, you just put your parameters in and you're calling it.
Right. Okay. Anybody else got any questions on the AC motor components? Real quick, you will see on these motors, you will see some, I'll show you, you'll see some thermostats or heaters, overload protection devices. You see them a lot on the submersible pumps. In the control cable, you see the thermals. Those are actually these devices. I don't know if you'll be able to see these or not, but when you get a break or when we get up here later, you can come up here and look at them. All it is a thermal overload device. When it heats up to a certain temperature, it opens up. It opens a circuit. But that's a component that they use in the motors. You might see one that's got a heater in it. You might have a motor, you probably see them in a utility, that's got what we would call a space heater in it. All it is a heat strip, and you've got it plugged in to 240 volt. This is where you're coming back to the power source that this gentleman talked about earlier, that there's a separate power source. You may even have a separate power source that powers this space heater because it powers it when it's not running. When this motor shuts off, this space heater comes on to prevent condensation inside the motor. But you don't see them that often. I don't know if you all do. If you've got questions about any of it, ask me. Anybody got any questions? Any more questions on AC motor? I like all these questions. Making my life easy.